Hey class, it's Mr. Chang. We're going to talk about 7.3, future value of a simple ordinary annuity today. Okay, so first off, I want to say congratulations on making it through this school year. We only just have annuities to talk about, these simple ordinary annuities. And there's two lessons, future value and present value, which is the one after this. And then there's a final week of lessons, and I really just made that nice and simple for you guys. You guys can just watch some financial videos, and that's just about life lessons that people are learning about how to manage their finances and things like that. They're pretty entertaining videos. You guys can do that. It's just some content. Okay, so future value of a simple ordinary annuity. Let me get at it here. See, the goal to talk about here is to really introduce the concept of like compound interest of an investment. How much is something going to be worth with compound interest, which we already know. But, this is like a deposit where you make regular deposits on. A savings where you make regular deposits on. The previous concept, when it just talked about compound interest, is if I take a whack of money and stick it in a savings account and then later come back to it and it's making interest, and how much money did it make for me? That's the idea. But what if I take that whack of money, put it in an account, and then also regularly, like once a month or once every 6 months or once every 2 weeks, whatever I do, deposit extra money on it, right? A consistent amount, like $200 every month, or $50 every week, or $50 every 2 weeks, something like that. If I was to put that money into the account, what would happen to the total money? Sure, it's gaining compound interest, but it's also gaining the money I'm putting in, which also gains compound interest. Okay, so that's what the annuity is. It's really compound interest, but you're also making regular payments in. You guys get the idea? All right, so let's go through three terms here. So an annuity is a series of regular equal payments paid into or out of an account. Okay, that's an annuity. A simple annuity is an annuity for which the compounding period is equal to the payment period. So, how often something compounds, the concept compounding, it could be like, semi-annually or bi-monthly or monthly, whatever it is. That compounding period will be equal to how often you put money into it as well. Okay. In fact, you would do it on the same dates. And then an ordinary annuity, here, when we say the word ordinary, we're talking about is when deposits are made at the end of each equal time interval. At the end. You can also make them at the beginning of equal time intervals, but we're not doing that. We're making it at the end of each equal time interval. So if we're doing it at if we're making monthly payments, or deposits, and those deposits will happen at the end of every month as opposed to the beginning of the month. And it does affect, like, for instance, the interest that accumulates. Okay, so in this course, we are only talking about annuities that are both ordinary and simple. Okay, we're only going to talk about those. Okay, so let's get to it. You really only have two formulas you got to understand, and the first one is for future value here. Okay, the future value of an ordinary annuity, again, a compound interest investment where you're making regular deposits, is the amount of your regular deposits, okay, and the compound interest formula factored in over here as well. Okay, we are going to start exploring these situations. So the total value of all the deposits at the end of the last time interval is called the future value of the annuity. Okay, that's the FV. The number of compounding periods is N. A deposit or payment, PMT, is made at the end of each period for that many periods that we're talking about. And the deposits earn interest at a rate of interest per compounding period, right? Remember, so I is equal to R divided by your compounds per year. Okay? And we talked about all those different parts. So let's just see all this stuff in action here. Let's get at it. Example 1. $250 is invested quarterly, into an account that pays 3.8% per annum, compounded quarterly. Determine the amount of the investment after 5 years. All right. So determine the amount of the investment after 5 years. We are talking about that future value. So we're going to start by taking down the formula. FV is equal to PMT square bracket 1 plus I to the exponent n minus 1 divided by I. So let's just take a moment and write that in. Here, PMT times 1 plus I to the exponent n minus 1, all divided by I. Let me just double check to make sure. Got it good, lined up nice and good. So we're trying to figure out the FV. Determine the amount of the investment after 5 years, right? So the amount of the investment, that's FV. Okay. What else do we know? Well, we've got 5 years. That's the amount of time. That's going to be interesting to know. We got 3.8% per annum, 3.8% per year, compounded quarterly. Okay, and $250 is your deposit. So let's write them out. We got variables, PMT, right? We know that's $250. You're going to make regular deposits of $250 every quarter, right? What else do we have? We have I. Okay, so I, remember, is equal to R divided by your compounds per year. R is 3.8%, which we have to divide by 100 to turn into a decimal, so 0.038, right? Because the decimal from 3.8 has to slide over twice when you divide it by 100, okay? Not 0.38, but 0.038. And then your compounds per year is quarterly 4 times. Okay, and if you do 0.08 divided by 0.038 divided by 4, you're going to get 0.0095. That is the interest rate as a decimal we're going to use here, okay? What about N? N is equal to your compounds per year times the number of years you go for, because we're trying to figure out how many total compounds would happen. Well, if you look at it, we are going for 4 compounds every year, and we are going to go for a total of 5 years. Okay, so your total amount of compounds is going to be 20. Cool. All right, let's punch in the details to see what we got here. So FV is equal to your PMT, which is 250 square bracket 1 plus I, which is 0.0095 to the exponent. Let me shrink down a little bit so we can see better. To the exponent 20. Subtract 1, close the square bracket, and divide it all by I again, 0.0095. Okay, I'm going to write FV is equal to, now be very careful, you want to do the bracket, inside bracket first, so you want to add these, put it to the exponent 20, subtract 1, and then you want to multiply that answer by 250, and then divide it by 0.0095. Some of you guys have a good scientific calculator where you might be able to punch in everything at the same time. I'm just going to freeze the screen and then reveal the answer. Okay, did you get this? Boom. Right? Therefore, in 5 years, the investment will be growing, right? Because it's $250 that you put in every quarter, but it's also earning interest as you do that, will be worth $5,478.04. And some of you guys are like, well, did it even grow in amount? Well, think about it. The answer is yes. Because if there was no interest, all we would have to do is take $250, right? Which is your quarterly payment, and times it by 4 times per year, and times it by 5 total years. Or the same thing as 250 times N. That's your deposits. Your total amount of deposits is 250 times 20. If you entertain that for a second, 250 times 20 only gives you $5,000. So how much interest did you make? $478.04. Okay? Got it? All right. And if you really want to talk about that, we could talk about I, right? You can say I is equal to future value subtract your present value. I is equal to that $5,478.04, right? But your present value is really a combination of your PMTs, your payments, times the amount of deposits that you make, which is N. Okay? And if you work this out, is equal to 5,478.04 subtract, this is like 5,000, so you get $478.04. Compound interest earned. Pretty wicked. Here we go. Suppose you deposit $100 every month into an investment account that pays 6% compounded monthly. $100 every month into an investment account that pays 6% compounded interest every month or monthly. What is the total value of these regular deposits after 4 years, and how much interest has the annuity earned? Okay? All right. So, start off always by understanding what you're trying to find. What is the total value? Okay, we're going to do this. The total value of the regular deposits after 4 years. Okay, that's with the interest that it's earned. Okay, and we are going to find all those other important details every month. That's monthly, 6% compounded monthly. What is the regular total value of these regular deposits after 4 years? So we start off with the formula. FV is equal to PMT, square bracket, 1 plus I to the exponent n minus 1 all over lowercase I. Okay, and I'm going to let you try to finish this question up yourself. I'm going to get you to pause the screen and do that, and I'll reveal the answer after a countdown from 3, 2, 1. Did you get this? Right? See, the reason why I start with a formula all the time is, just let me backtrack. Those of you guys who might still be a little bit lost, is start with a formula because, you want to find FV. So you're like, okay, well, give me the formula. That's a no-brainer. You don't have to think about that. You just write out the formula. Like, typically, I'd even give you that, or you'd be given that on a formula sheet. Then, after you write down the formula, you're like, okay, I have to find this, the PMT. Oh, there's an I there, and there's an N. I mean, these ones, I'm just going to punch that in the calculator. That's another I, is the same thing. So there's 3 green things I need to figure out. So the first one is PMT. Scan, yep, it's 100. I, well, that's R divided by CY. I have to do the calculation. That's a 6%, right? Is 0.06 divided by monthly payments. And then you get your I value, right? And your N value, you've got to calculate that. And that's your compounds per year, which is 12. And your years that we go for, which is mentioned over here, is 4. And then you're going to get 48. You find PMT, I, and N, plug them in, and boom. Okay? Especially if you have a calculator that you can just do it all in one shot with, there's your answer. Then you have to calculate I, right? And you just go, I is equal to future value, subtract present value. So you just plug in the future value, which you just found, and then you subtract the present value, which is the total value of all the deposits that you made. So that's $100 times 48 of them, right? And if you subtract them, you get $609.78. That's it. We got one more question for you guys. Michelle plans to buy a house 4 years from now. To save for the $30,000 down payment, she decides to make equal monthly deposits at the end of each month in a savings account that pays 5.5% per annum, compounded monthly. Determine the amount of the regular deposit Michelle should make in order to save for the down payment. Whoa. Somebody threw a curveball at us. Let's see if we can catch it and figure it out. Determine the amount of the regular deposit. This is saying, what is the PMT equal to? Okay, that she should make in order to save up for the down payment. She needs all that money to eventually be worth, Michelle that is, $30,000. So that $30,000, I'm going to come back and argue, is the future value. Okay, so We got a lot of details. We got 4 years. She decides to make equal monthly payments. Of course, that's the PMT at the end of each month, right? Because that's simple, ordinary. In a savings account that pays 5.5% per annum compounded monthly, okay? So I think that's all the details we need. We start with the formula. So FV is equal to PMT, square bracket, round bracket, 1 plus I to the exponent n minus 1, square bracket, all divided by lowercase I. Let's see if we have all those different parts that we need. PMT, do we have it? No, actually, we need to figure out PMT. Whoa. This puts us at a very interesting situation. All right. So if we have to figure out PMT, that's this part right here. We need to figure that out. That's right here. Then we need to isolate that. And you could sub in everything and then isolate it, but actually why don't we just isolate it first? Okay, let's just working with these variables. It's better than working with like whatever numbers we plug in, because you're going to be tempted to move them around. You're not sure what happens with the signs. And, let's just try to take always the smarter path and the easier path, especially if it is both. So let's isolate the PMT. I'm going to multiply I to both sides. Okay, and I'm now going to get this. V times I, okay, because I multiplied I to both sides, times I, and get FEI, right? And that's gone. And then I have to divide both sides by this entire block, this square bracket, this 1 plus I to the exponent n minus 1. So if I divide this whole thing by square bracket, 1 plus I to the exponent n minus 1, I've effectively isolated PMT. And you can, switch them around if you'd like. So some people would go, okay, well, isn't that the same as this? Yes. Especially for the people who need to see it written this way, be my guest. Okay. All right. Let's see if we have everything we need. Let me get a little bit more space here. Take your time, plug in the FV, figure out I, figure out N, okay? Plug it in, work it out. I'm going to freeze the screen and be back in 3 seconds with the answer. 3, 2, 1. All right, so first off, I'm going to take a little bit of a halfway point pause here just to make sure. Did you guys find these same values? So the future value is 30,000. That the I value is 0.055 divided by 12, which would give you this. That's a repeating decimal of 333333333 repeating. So I'm just going to leave it like this as a decimal. And then I have the N value, which is monthly times 4 years, which is 48 total compounds. Okay? And in 3 seconds, I'll show you the answer. 2, 1. Did you get this? $560.19. Therefore, you have to make, therefore, the quarterly payment is $560.19. Is it quarterly? No, I'm crazy. It's monthly. Correction. Monthly payment is $560.19. So, like some of you guys would be like, okay, so you're telling me that if you make monthly payments of $560.19, then after 4 years, you're going to have $30,000? Yeah, you put in $560.19 each month for a total of 4 years. At the end of that 4 years, you're going to have $30,000. Well, let me ask you a question. If you take $560.19 and you times it by the N value of 48, do you get 30,000? And is your answer higher or lower than 30,000? And then the bigger question is why? Because if you know why, then you understand this stuff. Okay? Good. I got some practice questions for you down here. It's page 107, 108, 1 to 4, 6 to 8. And these questions also have the answers, of course, attached to the questions. So you just flip open to the next content tab, and you'll be able to see these practice questions. All right, guys and girls, that's the end of this lesson. Stay tuned. We got one more lesson coming up as well. Talk to you later. Goodbye.